using data flow modeling. So data flow modeling low, so we will try to design one sequential circuit using data flow modeling, and then we will go to behavioral modeling. Okay, so I will copy paste a code. Okay, you try to identify so what it is. నేను టాప్ మాడ్యూల్ ఒక్కటే నేను పెడతాను. యూ ట్రై టు ఐడెంటిఫై యాక్చువల్లీ వాట్ ఇట్ ఈస్. Not complete code. Okay, not complete code. So here if ఇక్కడ ఒకటి share the notepad. You can see here what is this. You have one universal shift register. Okay, so you have used conditional operator here. Okay, and 4 assign statements you have used. So I ఒక shift register use చేశాను, and here 4 conditional statements I have used. Okay, shift register కి 4 conditional statements use చేసిన తర్వాత సో ఇది ఏం సర్క్యూట్ అవుతుంది? కెన్ యూ గెస్ అండ్ టెల్ మీ. ఇక్కడ నేను అదే రివర్స్ ఇంజనీరింగ్ ప్రొసీజర్ ఫాలో అవుతున్నాను. ఓకే, సో దిస్ ఈస్ ద టాప్ మాడ్యూల్. ఓకే, దిస్ ఈస్ ద టాప్ మాడ్యూల్. ఈ టాప్ మాడ్యూల్లో in this top module you are using universal shift register. Okay, for this universal shift register, this is universal shift register. So you have clock TLK and you have D, okay, as one input, and you have SD, RD, Q bar. Okay, Q bar. Yes, sure. Got it. Okay, student Q bar. Okay, so what is this actually? Assign D is of 4 bits. Okay, it is of 4 bits. Okay, so D 4 bits only. So that means D of 1, D of 2, D of 3, and D of 0. Okay, so D is of 4 bits, and Q, whatever here you are getting, Q is also of 4 bits. Okay, so Q of 0, Q of 1, Q of 2, and Q of 3. Q bar also will be of 4 bits only. Q bar of 0, Q bar of 1, Q bar of 2, and Q bar of 3. Okay, so now what you are doing, you are what this is one signal, CEN is one signal, control enable. Okay, so if the signal is equal to 1, what you are assigning, let us suppose if you are assigning if D of 0, D of 1, D of 2, D of 3 are the inputs for this universal shift register. Q of 0, Q of 1, Q of 2, Q of 3 are the outputs for this universal shift register. You are checking the control enable. If it is equal to 1, what are you doing? You are assigning Q of 0 is equal to 0. This one you are making it as 0. So what you are checking again the control enable if it is equal to 1. Sorry, control enable is equal to 1 అయితే you are assigning Q of 0 uh, to your what D1. Okay, you are assigning the Q of 0 value, whatever the output you are getting here, you are assigning to your D1 here. Okay, or else you are assigning 0. And enable, you are again you are checking Q of 1 is assigned to D2, Q of 2 it is assigned to D3, and Q of 3 is assigned to D0. Okay, ఇది ఏంటి చెప్పండి, సింపుల్ సర్క్యూట్. You have got an idea now. Hmm. D of 0, D of 1, D of 2, D of 3. Yes, it is ring counter. Okay. So you are checking the control enable and you are assigning the values like this. Universal shift register tote, you are shifting the values. Okay. Now my question is, so now the question is designing a ring counter. Okay. To design a ring counter, actually what do we require for the design of a ring counter? Ring counter design cheyali ante మనకి ఏం కావాలి? The module ring counter is the top module అంటే, so you need to design దీని లోపల మాడ్యూల్ ఒకటి ఏంటి, యూనివర్సల్ షిఫ్ట్ రిజిస్టర్ USR. Anyone tell me? Universal shift register design చేయాలి అంటే what are the modules that you require? Not getting you. Yes. D flip flop. Okay. D flip flop design చేయాలి అంటే what is the module that I need? D flip flop design చేయాలి అంటే SR flip flop. Okay. So first you have to start with SR flip flop. Okay. So second, what you need to do? Second, you need to from SR flip flop, you need to instantiate SR flip flop and you need to design D flip flop. And D flip flop you need to instantiate one time, two times, or three times depending upon how many bits you are counting. Okay, so that is what is that? What is this? From D flip flop you are designing your universal shift register. Universal shift register instantiate చేసుకొని సో మీరు రింగ్ కౌంటర్ డిజైన్ చేస్తున్నారు. Okay, so if we start from here, SR flip flop. You know the code for SR flip flop. So I am not doing it, just copy paste. So this is not SR latch, SR flip flop we need to take. Okay, let me open this word open this. So once after finishing this, we will close this data flow modeling. Okay, this is your SR flip-flop. చూడండి. Okay, so first this is SR flip-flop module, and the second module is from SR flip-flop. We are going to see design the D flip-flop. So this is your D flip-flop module. Okay. This is your D flip-flop. So then from D flip-flop we have universal shift register. So how many D flip-flops you have taken here? So you have taken 4 D flip-flops. Okay. So that means it is a 4-bit ring counter. Have instantiated universal shift register. After that you have got the ring counter. Okay. So this is ring counter module. So they are instantiating universal shift register. Right. Okay. So we will see what the each one. Okay. So we'll see each one in detail. So this is SR flip-flop kada. To what is this SR flip-flop? How did you design instantiating 2 NAND gates? Okay. So instantiating, you have taken 2 NAND gates. 2 NAND gates. What is this? What is the output? Output is Q, and Q bar is the output. So this is SB. Okay, RB. Okay, SB and RB. And you have D also as the input. Okay, one more inverter you have taken. This is nothing but your D bar. So D bar, and one more input that you need to give for this flip flop is nothing but D bar. One more is nothing but your Q. You should give. Okay, this is your SR flip flop. You have done it. I need not explain about this SR flip flop. Now what you have done is you have instantiated this SR flip flop 3 times. Okay, 3 times you have taken this SR flip flop and you have designed your D flip flop. See, why do we use D flip flop is everywhere. Okay, sequential state machines or melee circuits or Moore circuits. If you want to synthesize any design, you will go with D flip flop because see D flip flop without with you can easily realize using D flip flop. Why? Because it is easy to understand. Okay, so there is no toggling in D flip flop, and also like JK, there is no race around condition in T flip flop. It is easy to realize, and I also told you there is a concept of scan chain by using the D flip flops. Okay, so uh, see here we have an SR flip flop. SR flip flop design చేసిన తర్వాత 3 times you have instantiated this SR flip flop. Okay, so this SR flip flop module you have instantiated for 3 times. You can see here. So this is one SR flip flop which is having inputs as you can see SB, RB, and here you have SB, RB, D and DB, right? D and DB are the inputs for your SR flip flops. and here output is Q and Q bar. Like that, you have instantiated three SR flip-flops kada. So ఇక్కడ ఒకటి, and you can instantiate ఇక్కడ ఒకటి తీసుకుందాం, and here also one block you can take. Here you have SB. Okay, so here you have RB, anything D and DB. Okay, similarly Q bar. Here also you have SB, you have RB and D, DB. Okay, you have Q and Q bar. Okay, so this is your SR flip three instantiations you have done. Now you can see what is the what is this SB, D, RB, DB, Q and QB, right? Port mapping cheyali ikkada. What you have to do with the port mapping? So what is the sequence here? You see the sequence here. What is the sequence that you follow? SB, D, RB, DB, Q, QB. Okay, so SB anante this is nothing but ikkada emundi, SB is nothing but this is first SR flip flop, this is the second instantiation, and this is the third instantiation. Let us suppose first, second and third తీసుకుంటే SB, what is the name of SB here? SDD. What is the name of D? What is the name of D here? N2B. D is ported with N2B. Okay, D is ported with N2B. And next, what is RB? RB with RDD. What is the name is RDD. Okay, so ఇవన్నీ brackets లో పెడుతున్నాను నేను. Okay, D is with N2B. DB is mapped with clock pulse. This is the clock pulse. Okay, DB is mapped with clock pulse. Whichever I do old what is that? Old variable names. Okay, so I'm putting in brackets. Okay, so see here, Q is nothing but N1. QB is mapped with N1B. Q is N1. Okay, QB place lo em vachindi? N1B. Okay, so this is what. Now take this second flip flop. The second flip flop lo SB is nothing but your N1B. Okay, this is nothing but your N1B. Okay, so what is this? CP. Okay, so D is nothing but your CP. This D is nothing but your CP. Okay, so next RB is nothing but, what is RB? దీంట్లో RDD. RB is nothing but RDD. I am just striking off the old these things. Okay, DB place లో ఏముంది ఇక్కడ చెప్పండి. సెకండ్ దాంట్లో DB place లో ఏముంది చెప్పండి. 1 2 3 4 DB కదా. DB place లో ఏముంది? 1 2 3 4. Here you have D. Okay, so these are the after instantiation you are giving new names to all the ports. Okay, N2 and N2B. Okay, here Q is N2 and Q bar is N2B. Now take the second, what is that? It is second flip flop kada. Second flip flop is that. So this is the second flip flop. Now third flip flop chudandamma. This one is done and this one is done. Now what is this? SB is nothing but SDD. RB enti ikkada? N1B. What is your D? D is your, what is your S? Sorry. So SB is nothing but your SDD, third danki. So what is this? D is mapped with N1B. D is mapped with N1B. Okay, so next SD is mapped with RDD. Okay, SD is mapped with RTD. SD కాదు కదా, what is this? Here we should see here కదా. SB is mapped with STD, and next what is this? D is mapped with N1B. This is correct only. D is mapped with N1B, and next RB is mapped with here. RB is mapped with what? RDD. Okay, RB is mapped with RDD. Okay, so I think this one, it is mapped with RDD. Okay, and DB is mapped with N2. Okay, DD is mapped with N2. Okay, and Q and Q bar are mapped with Q bar only. Okay, so now wherever the common points are there, we need to connect STD. We need to connect this STD like this. Okay, and N1B you should connect it like this. Okay, so wherever the common terminals are there, you can connect RTD is there, and you can connect the RTD like this. So N1B connection is there. N2B, where is this N2B? N2B, I will connect it like this. Okay, so here you are giving the clock pulse CP. Okay, you are giving the clock pulse CP. And N1, where is this N1? N1 ఎక్కడైనా కనిపిస్తుందా మీకు? Where there is N1? N1 bar is there. N1 bar is there. You connect here this N1 bar. Okay, so this is your N1. Do I need to connect anything else is there to connect? Common గా ఉన్నవి, సిమిలర్ నేమ్ ఉన్నవి మీరు కనెక్ట్ చేస్తున్నారు అన్నమాట. Okay, that is N1, and here you have, this is N1, and here you have N2. Okay, wherever it is clock pulse is there, clock pulse and clock pulse you will be connecting like this. Okay, so this is your D, N2, N1, N2 bar.
N2 connect out.
N2?
2 లో N2, 3 లో N2.
ఇక్కడ కనెక్ట్ చేశాను. మళ్ళీ తర్వాత 2 లో N2 ఎక్కడ ఉంది? 2 లో N2, 3 లో N2 కనెక్ట్ చేశాను. N1 కి ఏదన్నా కనెక్షన్ ఉందమ్మా? చూడండి. N1 ఒకటేసారి కనిపిస్తుంది. ఓకే, so this way you can take a piece of paper and you can try it. Okay, this way you will instantiate. This is nothing but the D flip flop using SR flip flops. Okay, so now this is the ఇక్కడ ఏంటిదనంటే సెకండ్ దాంట్లో టాప్ మాడ్యూల్ వచ్చేసి D flip flop. Okay, sub modules are SR flip flops. These are the sub modules. Okay, now coming to the universal shift register. Okay, coming to the universal shift register. Universal shift registers low. Now, okay, universal shift register low, we have to instantiate this circuit for how many times? 4 times we need to instantiate the circuit. Okay, D flip-flop circuit, we need to instantiate it for 4 times. Okay, so universal shift register okay, in this universal shift register, what you need to do is you need to take the D flip-flop for the 4 times you need to instantiate. You are instantiating it for 4 times. Okay, so see here the order you should not change again in D flip-flop. Here you have clock pulse, D, SD, RT, Q and QB. Okay, so here but the same we need to take. You have clock input. Okay, so you have clock input for all the flip flops which are taking clock is the first signal. Okay, so clock, so you are applying first signal as clock. Okay, so this is clock signal. Your this is clock is the first signal. D0, D1, D2, D3. Okay, D0, D1, D2, D3. So here you have D0. Okay, D1, you have D2 and D3. Okay, D0, D1, D2 and D3. So what is this SD0, SD1, SD2 and SD3, right? Okay, this is also, see here SD and RD set to reset are also inputs. Okay, so here I am giving the inputs for this SD1, okay, SD0, SD1, okay, SD2 and SD3 are the inputs. Okay, next RD0, RD0, RD1, here you have RD2 and here you have RD3. Okay, so these are also the inputs. And for the first Q0, Q1, Q2, Q3, you can see Q low, Q outputs, Q0, Q1, Q2, Q3 are the outputs. Okay, so here I am taking the outputs. This is Q0, Q1, so here you have Q2, Q3, and similarly QB of 0, QB of 0, QB of 1, QB of 2 and QB of 3 are the outputs for the universal shift register. So ఇక్కడ నుండి Q0 I'm just extending. So Q1 I'm just extending this ఇవి inputs. Okay, these are the inputs. I'm giving the direction. Okay, so Q0 is the output, Q1 is the output, and here Q2 is the output. Okay, Q2, Q of 2 and the Q of 3. These are the outputs. Okay, these are the outputs from the flip flop. This is just the design of universal shift register. You are not giving doing any operation. మీరు ఇలా కనెక్ట్ చేశారు అంతేగాని universal shift register. So when you give the clock pulse, okay, when you give the clock pulse, okay, the bits will be shifted D0 to D0 to D1, D1 to D2, D2 to D3. Like the bits will be shifted. Okay, either what left side or right side. ఇక్కడ మీరు you have not mentioned the shift and you have not given anything, just this is the connection ante. Okay, shift register ki you have not given left shift or right shift, any shift you have not given, operation em cheyaledu, this is just the instantiation, that's it. Okay, so this universal shift register, it will operate like a ring counter, or it may be left shift register, right shift register, whenever we are giving certain inputs. Okay, now here universal shift register is the top module. Okay, so this is the, okay, D flip flop is a sub module. Okay, ఇవన్నీ కూడా sub modules. So D flip flop D flip flop is a sub module. Inside the sub module you have SR blocks. Okay, so now we are instantiating this one and designing the ring counter. Okay, ring counter design lo universal shift register ni I am instantiating. Okay, this is universal shift register which I am instantiating for the design of ring counter. Now ring counter is the top module. Okay, ring counter is the top module. This is the sub module for my design. Here what I am doing is I am taking the same thing. Okay, I am taking the same thing. You just for this universal shift register is there, no, this universal shift register దీని లోపల ఈ బ్లాక్ అంతా ఉందన్నమాట. For this you see for this universal shift register you have clock. Okay, you have D, ఇందాక చూపించింది, you have SD. Okay, you have RD and you have Q and you have Q bar. Okay, direction కోసం I am putting like this, that's it. So that's it. Okay. So you need to check whether D of 1 is equal to, you are giving an enable signal also here. Okay. Control enable signal also you are giving apart from this. Okay. C enable is control enable signal also you are giving. Okay. So ST is of 3 bits, RD is of 3 bits, input D is of 3 bits. Okay. Q is of, sorry, Q is only 4 bits, 3 kaadu. Q bar is of 4 bits, everything is of 4 bits. And here you are taking D as a wire, you are considering D as a wire. Okay. So for this universal shift register, you need to check whether D of what is that control enable 1 unte, what you are doing, దీనికే see, you are giving one control enable to this shift register. Okay. So if control enable is equal to 1, what you are doing, control enable is equal to 1, whatever the q of 0 value is there, q of 0 value is there, this value you are giving to d1. Okay. Q of 0 value ante, so this one, your q of 0 is shifting here. Okay. Q of 0 is shifting here, okay. So then q of control is equal to 1 ఉన్నప్పుడు q1 is q1 is shifted to here, that is dq, d2, q1 will become d2, q2 will become d3, q2 will become your d3. Okay. And q3 will become your d0. Okay. So again, this is nothing but ring counter operation. Okay. So shifter ante only it will shift like this. Whatever the last bit there is there, it is not assigned here. Okay. So that is shift register. But ring counter ante whatever the final bit is there, okay, D of 3 will come here again and it will assign to what is that, sorry, q of 3, whatever the last bit is there, it will assign to d0. Okay. It will assign to d0. Again, this is a repetitive process. Okay. It is a again you check when control is equal to 1, again the bits will be shifted like this. Okay. You will as bits will be shifted like this. This will what is how many times you want this function to happen, it will happen those many times. Okay. Finally, I will conclude this ring counter like this. You have what is this, d of దీంట్లో చూడండి, d0, d1, d2, d3. Okay. d0, d1, d2, d3, and q0, q1, q2, q3. Okay. So you check whether control enable is equal to 1. What will you do? What will you do? q0 value, you assign this value, you put this value here. Okay. You put this value here, you put this value here. Okay. Shift ante normally this value will be deleted. Okay. ఇక్కడ ఒక 0 append అవుతుంది. But as it is a ring counter, you q3 value you assign here. Okay. So again, this is one time shifting. So again, if you, for the next clock cycle, again, if you want to, for the next, if you are taking positive or negative edge trigger of the clock, for the next clock pulse, again the same thing will happen. Okay. So new values again they are shifted like this. Okay. This is ring counter. Today, this is only one thing I am giving. Okka program chalu ring counter okka module me design cheyandi valla. So ఒకటి చాలు. Now we'll quickly move to behavioral modeling. మీకు ఇక్కడ ఏమైనా డౌట్ ఉంటే అడగండి కౌంటర్లో. I hope you are able to see the PPT. కనిపిస్తుందమ్మా? Yes.
Yes, ma'am.
Now behavioral modeling. So you know now clearly gate level modeling, structural modeling. Gate level and structural both are same. I told you, right? Gate level, structural, and you know data flow modeling. So can you tell me what is the difference between data flow modeling and gate level modeling? Anyone? You can unmute and talk. What is? చెప్పండి. Mm, 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 mm. See, gate level modeling means so data flow modeling is we are using continuous assignments. Okay, continuous assignments we are using. So gate level modeling means we are instantiating the primitives. Okay, instantiating the predefined primitives from the library is called as gate level modeling. So data flow modeling is nothing but using the what is that? ఇందాక నేను ఏం చెప్పాను? We are using డేటా ఫ్లో మోడల్ ఇందాక చెప్పాను ఏంటి చెప్పండి డేటా ఫ్లో మోడలింగ్ అంటే కంటిన్యూస్ అసైన్మెంట్స్ we are giving. Okay. కంటిన్యూస్ అసైన్మెంట్స్ we are giving in data flow modeling. ఇంతవరకు ఇక్కడ సి గేట్ లెవెల్ మోడలింగ్ లో అయినా డేటా ఫ్లో మోడలింగ్ లో అయినా సో వాట్ ఆర్ ద థింగ్స్ వీ హ్యావ్ సీన్ ఆపరేటర్స్ చూసాము తర్వాత డిఫరెంట్ టైప్స్ ఆఫ్ అథమెటికల్ ఆపరేటర్స్ లాజికల్ ఆపరేటర్స్ రిలేషనల్ ఆపరేటర్స్ షిఫ్ట్ ఆపరేటర్స్ ఓకే సో ఎవ్రీథింగ్ ఆల్ ది ఆపరేటర్స్ వీ హ్యావ్ సీన్ తర్వాత డిలేకి వచ్చేసరికి సారీ వాట్ ఈస్ దట్ delay, gate delay, gate delay, net delay, wire delay. Okay, all these things we have seen. Okay, సో మనకి ఎప్పుడు కూడా వాట్ ఇంటర్ అసైన్మెంట్ డిలే అనేది అండ్ there are some other concepts also. Minimum delay, maximum delay, typical delay also we have seen. Okay, so many concepts we have discussed so far, but here అవన్నీ కూడా ఏంటిదనంటే ఒక 30% అనుకోండి మనం నేర్చుకుంది. సో మాక్సిమం థింగ్స్ యాక్చువల్ వెరిలాగ్ ఇట్ ఈస్ వి విల్ లెర్న్ ఇన్ బిహేవియరల్ మోడలింగ్ ఓన్లీ. ఓకే, సో గేట్ లెవెల్ డేటా ఫ్లోలో మనం నేర్చుకుంది నథింగ్ అదంతే. ఓకే, సో మనం నేర్చుకున్నంత వరకు నేర్చుకుంటే చాలు గేట్ లెవెల్ డేటా ఫ్లో. యాక్చువల్ వెరిలాగ్ వాట్ starts with behavioral modeling only. So in the beginning itself I told you what do you mean by behavioral modeling. Actually I'm not asking you the definition. So if there is data flow modeling and if there is structural modeling, what is the need of going for this behavioral modeling? అలా ఏ సర్క్యూట్ అయినా డిజైన్ చేయొచ్చు కదా 2 మోడలింగ్ స్టైల్స్ యూజ్ చేసి. ఈ మోడలింగ్కి వెళ్ళడం ఎందుకు? ఇట్ ఈస్ హయ్యర్ లెవెల్. అదే ఎందుకు హయ్యర్ లెవెల్? హై లెవెల్ మోడలింగ్. ఎస్, గుడ్ ఆన్సర్. యాక్యురసీ అంటారు, ఈజీనెస్ అంటారు.
లాజిక్ తెలిస్తే డిజైన్.
యా, ఇప్పుడు చూడండి సింపుల్ థింగ్ అమ్మా, సింపుల్ ఎగ్జాంపుల్. ఇప్పుడు ఫ్లిప్ ఫ్లాప్ ఇచ్చాను అనుకోండి డిజైన్ చేసేస్తారు, కౌంటర్ ఇచ్చాను అనుకోండి డిజైన్ చేసేస్తారు మీరు. ఓకే, నేను ఒక సీక్వెన్స్ డిటెక్టర్ ఇస్తాను. ఓకే, సీక్వెన్స్ డిటెక్టర్ ఇస్తే మీరు డేటా ఫ్లో ఇంకా స్ట్రక్చరల్ మోడలింగ్ యూజ్ చేసి డిజైన్ చేయగలరా? 1010 సీక్వెన్స్ డిటెక్టర్ ఇస్తాను, నాన్ ఓవర్లాపింగ్ సీక్వెన్స్ డిటెక్టర్ అని. So is it possible to design? It is very difficult to design using gate level modeling. Okay, ఏదో ఒక మీలీ సర్క్యూటో మూర్ సర్క్యూటో I will give you. Okay, So you don't know how to design actually. So it చాలా కష్టం అవుతుంది డేటా ఫ్లో స్ట్రక్చరల్. ఇఫ్ మీరు రాస్తూనే వెళ్తారు, ఇన్స్టాన్షియేట్ చేస్తూనే వెళ్తారు, కానీ యూ విల్ నాట్ గెట్ ద డిజైర్డ్ అవుట్పుట్. See, as this data flow as well as structural modeling, if you exactly know the logic equations, or if you exactly know how many logic gates should be used, you should have the idea. Okay, but in behavioral modeling general ga entidi, what is that example తీసుకోండి, వాషింగ్ మిషన్ అనుకోండి, రిన్స్, వాష్, డ్రై, ఇంకేముంటాయి ఫంక్షన్స్. There are 3 to 4 functions will be there in washing machine, right? అవి స్టేట్స్ కదా. రిన్స్ ఒకటి, వాట్ ఈస్ దట్, స్టార్ట్ తర్వాత రిన్స్ ఒకటి ఉంటుంది, డ్రై ఒకటి ఉంటుంది, ఓకే, వాష్ ఒకటి ఉంటుంది. ఓకే, సో 4 or 5 ఆపరేషన్స్ విల్ బి దేర్. ఓకే, ఇవన్నీ కూడా ఏంటి, వాట్ హ్యూమన్ అండర్స్టాండింగ్ తోటి నేను ఫస్ట్ దిస్ ఆపరేషన్ ఐ షుడ్ పర్ఫామ్, సెకండ్ దిస్ ఆపరేషన్ ఐ షుడ్ పర్ఫామ్. సో ఇమీడియట్లీ ఆఫ్టర్ దట్, దట్ ఈస్ ఏంటిదంటే దట్ ఈస్ మై according to my requirement I want to design the circuit like that. Okay, it is not possible if I go data flow modeling or structural modeling. Just you can represent with the state diagram, నీకు ఏం కావాలో స్టేట్ డయాగ్రామ్ లో రిప్రజెంట్ చేసుకో. కానీ దాని డిజైన్ అనేది ఏంటిదనంటే దానికి నువ్వు మళ్ళీ లాజిక్ ఈక్వేషన్ ఆర్ ఎల్స్ లాజిక్ డయాగ్రామ్ గీయడం, స్టేట్ లో రిప్రజెంట్ చేస్తారు కానీ లాజిక్ డయాగ్రామ్ గీయడం అనేది చాలా కష్టం. ఓకే, ఈవెన్ సింపుల్ ఈ ట్రాఫిక్ లైట్ కంట్రోలర్ ఉంది కదా, రెడ్, గ్రీన్, బ్లూ, ఎల్లో. ఓకే, సో ఇది కూడా ఏంటిదనంటే డిపెండింగ్ అపాన్ ద ట్రాఫిక్ ఓన్లీ యు ఆర్ ఏబుల్ టు దీస్ వాట్ ఈస్ దట్ what is density of the traffic. Depending upon the density of the traffic, the signals should be changed actually. Okay, the signals should be changed. It should what is that, sensor should sense the where the traffic density is more, and according to that it has to change the signal. Okay, so all these things, these are this is these are made according to the, should be designed according to the requirement of human. ఓకే, హ్యూమన్ బ్రెయిన్ తోటి మాత్రమే డిజైన్ చేయొచ్చు అనమాట. ఓకే, సో బిహేవియరల్ మోడలింగ్, ఎనీ కాంప్లెక్స్ సర్క్యూట్, ఓకే, స్టార్టింగ్ ఫ్రమ్ స్టేట్ మెషిన్ టు memory chip, SRAM or DRAM or a CPU. Okay, so or else 64-bit ALU, or else it may be high speed memory. Okay, so whatever you want to design, or else a memory which is required for the AI application. Okay, so everything bus architecture may design cheyali anna, it's possible only with behavioral modeling. Okay, it's possible only with behavioral modeling. Okay, so in behavioral modeling only thing is you are mixing this Verilog with C language to mix up chesi, you are acquiring the desired function. Okay, so now if we go for behavioral modeling, so the assignment symbols you can see, ivanni kuda operators annamata. Identi equality operator, less than or equal to, greater than or equal to, or this is negation operator. Okay, so reg ante n is declared as a variable reg. Okay, so n is equal to m by l. Anything you can use. If 2 procedures are placed within always block, they are carried sequentially in a specified order. So we will discuss all these things line by line. Now బిహేవియరల్ మోడలింగ్ లో మోస్ట్లీ మీరు చూసేది ఏంటిదంటే ఇనిషియల్ బ్లాక్, ఆల్వేస్ బ్లాక్. ఓకే, సో two functions we will be using here, mostly 2 functional blocks, initial block, always block. Initial block generally we use in test bench programs లో మనం యూజ్ చేసాం కదా ఇనిషియల్ బ్లాక్. ఇనిషియల్ బ్లాక్ మీన్స్ whatever initial block lo #2 a is equal to 0, b is equal to 0, #3a is equal to 0, b is equal to 0, like that we were assigning, right? Okay, So assignments or whatever the activities or whatever the assignments which we are putting in the initial block, they are executed only once. Okay, so they are executed only once. నార్మల్గా ఇనీషియల్ బ్లాక్ లో మీరు ఏం చేస్తారు చెప్పండి? హౌ డు వి యు రైట్? ఇనీషియల్ అని రాస్తారు, తర్వాత బిగిన్ అని రాస్తారు, తర్వాత హ్యాష్ టు a is equal to 0, b is equal to 0, again has the a is equal to. So whatever the end, ఈ two statements లేకపోతే ఒక 100 statements ఇచ్చారు, whatever the statements are there, they will execute only once in the initial block. And coming to the always block అయితే, so here mostly we will be using always statement. Almost sequential circuit start అయినప్పటి నుండి we will be using always statements. So always at the rate of always at the rate of pause edge of clock అని ఇచ్చాను. Okay, pause edge of the clock a is equal to bn. See, b value is assigned to a at every clock positive edge of the clock. అంటే ఒట్టి ఫస్ట్ పాజిటివ్ ఎడ్జ్ దగ్గర ఈ స్టేట్మెంట్ ఎగ్జిక్యూట్ అయ్యి అలా ఉండదు. ఓకే, ఫర్ ఎవ్రీ పాజిటివ్ ఎడ్జ్ ఆఫ్ ది క్లాక్ ద b value is assigned to a. Okay, so this always whatever the, so you can give many statements like that: b is equal to c, c is equal to d. How many functions or how many activities you are giving under the always block, these activities will be executed on always basis. Okay, always basis. There is what no discontinuity, continuously for every positive edge of the clock, or else if you are giving at every negative edge of the clock. Okay, for every negative edge of the clock these statements will be executed. Okay, so here you can see the structure of the procedural block. You can see this is type of the block. Procedural block, and it may be always or it may be initial. Okay, so type of the block is always or it is initial. Okay, so type of the block at sensitivity list, this is the syntax. Okay, type of the block ante it may be initial block and it may be always block. I told you initial ante ఒకటేసారి ఎగ్జిక్యూట్ అవుతాయి, దాని కింద ఉన్న స్టేట్మెంట్స్. ఆల్వేస్ బ్లాక్ అయితే దాని కింద ఉన్న స్టేట్మెంట్స్ ఫర్ ఎవ్రీ ఈవెంట్ కి ఎగ్జిక్యూట్ అవుతాయి. ఓకే, సో అట్ ది రేట్ is symbol is indicating the event control, it is signifying the event control. సో ఎట్ ది రేట్ ఆఫ్ సింబల్ ఓన్లీ మనం ఆల్వేస్ బ్లాక్ కి మాత్రమే యూజ్ చేస్తాము, ఓన్లీ ఫర్ ఆల్వేస్ బ్లాక్. ఇనీషియల్ కి ఎట్ ద రేట్ ఆఫ్ సింబల్ ఉండదు. సెన్సిటివిటీ లిస్ట్ అంటే సో స్పెసిఫైస్ ద ఈవెంట్ అంటే అది పాస్ ఎడ్జ్ ఆఫ్ ది క్లాక్ అయినా అవ్వచ్చు. ఓకే, సో దట్ ఈస్ మేబీ నెగెటివ్ ఆఫ్ ది క్లాక్, ఆర్ ఎల్స్ పాజిటివ్ లెవెల్ ఆఫ్ ది క్లాక్, ఆర్ ఎల్స్ నెగటివ్ లెవెల్ ఆఫ్ ది క్లాక్. ఓకే, సో ఆర్ ఎల్స్ వెన్ క్లియర్ ఈజ్ ఈక్వల్ టు 1 అనేది, ఇది సెన్సిటివిటీ లిస్ట్ లో ఏంటంటే దెర్ ఇస్ వన్ కండిషన్. ఓకే, నాట్ కండిషన్, సో ఈవెంట్. ఓకే, ఇట్ ఈస్ కాల్డ్ అస్ ఈవెంట్. ఏ ఈవెంట్ క్లియర్ 1 ఉన్న ప్రతిసారి you have to execute these things. Next, after the always block or initial block, you need to give block of statements, you need to give begin end. అంటే more than one statement మీరు ఇవ్వాలి అని అన్నప్పుడు you have to use begin end block. సో బిగిన్ ఇచ్చినప్పుడు you can label, అంటే మీరు బిగిన్ ఇచ్చినప్పుడు సో block of statements you are giving, right? You can give the name begin. Okay, begin colon పెట్టి you can give the name. Okay, label 1. Okay, ఈ block కి you can give your own name. Okay, so procedural assignments అయినా ఇవ్వచ్చు, లోకల్ వేరియబుల్ అంటే a is equal to ఉంది. procedural assignments అయినా ఇవ్వచ్చు, if else statements. Okay, so you can whatever you want you can give, you can close within the begin end. Okay, so begin and ante all the activities when the block are enclosed within begin and construct. This is called one construct. Procedural statements from the body of, these are the procedural statements from the body of the block, and these are variables. Okay, సో మనకి ఏది కావాలంటే అది ఇవ్వచ్చమ్మా. దిస్ ఇస్ ద స్ట్రక్చర్ ఆఫ్ ది ప్రొసీజరల్ బ్లాక్. ఇది చాలా ఇంపార్టెంట్. యూ షుడ్ నాట్ ఫర్గెట్ దిస్. నెక్స్ట్ we will see begin and construct. So here there is only one statement, initial. Okay, #2. ఇది యాక్చువల్ గా ఎలా రాస్తారు అని అంటే initial #2 a is equal to 0. ఓకే, సో సింగిల్ స్టేట్మెంటే ఉంది కాబట్టి దీనికి బిగిన్ అండ్ అవసరం లేదు. ఓకే, for more than one procedural assignment initial block is required. Sorry, for more than one procedure all such statements are grouped between begin. Yeah, okay, so initial for more than, yes, for more than one procedural statement. Sorry, తప్పు చెప్పాను. Initial begin and initial తర్వాత, సో ఇనిషియల్ బ్లాక్ ఎప్పుడు యూజ్ చేస్తామంటే if we have more than one assignments. Okay, if we have more than assignments, a is equal to 0, b is equal to 1, c is equal to 0. So if you have more than one assignments, you will be using the initial block. So here 3 assignments are there. Excuse me. 3 assignments are there. These 3 assignments you should put in begin and block. Okay, so begin మనం యూజ్ చేసామంటే always you need to have an associated end declaration. Okay, so begin end constructs are nested అంటే ఒక బిగిన్ లో ఇంకొక బిగిన్ యూజ్ చేయొచ్చు. ఓకే, గ్రూప్ ఆఫ్ స్టేట్మెంట్స్. అండ్ అగైన్ యూ కెన్ యూస్ బిగిన్, యూ కెన్ యూస్ గ్రూప్ ఆఫ్ స్టేట్మెంట్స్. ఎన్ని బిగిన్స్ పెట్టాము? This begin and block will end here, this begin and block will end here, this begin and block will end here. This is called as the nesting of the begin and blocks. Nesting of the begin and blocks. Okay, so any block you can give the name to any block. Name ఇవ్వకున్నా ఏం ప్రాబ్లం ఉండదు అనమాట. I told you, right, what is that initial any block can be assigned a name, but it is not mandatory. Okay, so assigning names to block serves different purpose. Registers declared within the block are local to it, not available outside. So see, giving labeling your blocks, always it is advantageous only. Okay, if your program is very simple, okay, if your program is very simple, then you need not give any block name actually. But if your program is complex and multiple times you have multiple begin and blocks. Okay, if you have multiple begin and blocks, and if you have multiple registers declared within the block, that time you need to, if you give the names to your blocks, then you can recognize your blocks easily. Okay, you can recognize your blocks. This is nesting of the begin and blocks. Okay, so this is your intermediate. ఇలా ఉన్నప్పుడు నేమ్స్ ఇవ్వడం బెటర్ అమ్మ మీరు. This is innermost block, inner block. Okay, so begin and లో again one more begin and block here is here in begin and 2 more begin and blocks you are using. Block you need to give one name. For this begin and block you give one name. You nesting చేస్తున్నాం కదా, ఒక బ్లాక్ లో ఇంకో బ్లాక్, ఒక బ్లాక్ లో ఇంకో బ్లాక్ అలా వెళ్తున్నప్పుడు మీరు దీనికి A1 అని పెట్టుకోండి, దీనికి B1 అని పెట్టుకోండి, దీనికి C1 అని పెట్టుకోండి. If you are giving the names like this, you can recognize them easily. Okay, so next one here is initial construct. Initial construct అంటే, so set of procedural assignments within initial construct are executed only once. Okay, సో ఇనిషియల్ తర్వాత మనం ఎన్ని స్టేట్మెంట్స్ అయితే పెడతామో నేను ఆల్రెడీ చెప్పాను కదా, ఈ స్టేట్మెంట్స్ అన్ని కూడా దే ఆర్ ఎగ్జిక్యూటెడ్ ఓన్లీ వన్స్. నేమ్ ఆఫ్ ది బ్లాక్ యూ కెన్ గివ్ నేమ్ ఆఫ్ ది బ్లాక్. అయిపోయింది కదా initial construct. Now this is a small program which is representing the initial construct. A small program which is representing the initial block. So this is nothing but a test bench program. Test bench lo inputs are AB. Okay, so AB are the inputs. Okay, so initial begin is equal to 0, B 0, A again after 2 time steps A is assigned a value of 1, the 3 time steps b is equal to 1, and you are stopping this simulation at 100 nanoseconds. Okay, so if you are giving block of statements, I repeat once again. So initial low, whatever the big statements you are giving, so there are five statements, and this is one sixth statement. All these statements will execute only once. Okay, ila ఇవ్వాలి. This is a simple code to represent your initial prompt. Okay, so ఇక్కడ ఏంటంటే you can see this waveform here. Say waveform which is related to this one. This is related to this initial. Only it is executed once. Okay. So need not go for this waveform A and B. Okay, దీని ప్రకారం values change అవుతా ఉన్నాయి. Okay, here in behavioral modeling, we need to note that any assignment statement on the left hand side has to be a storage. This should be of storage type. Storage type ante it should be rich. Okay, rich or integer or real type of the variable. Right hand side can be a storage type or storage type of variable, reg integer. Okay, so ipudu a is equal to hash 2, a is equal to 1 tick b0 అన్నాను అనుకోండి. Okay, or else this is indicating a should be of rich type always. Okay, a should be of rich type. Okay, so it can be rich or it can be an integer, or okay, or it can be real type also. రైట్ హ్యాండ్ సైడ్ ఏదైతే ఉంటుందో వాట్ ఎవర్ ఇది 1 tick b0 అని ఉంది, కానీ ఇట్ మే బి ఒకవేళ b అనుకోండి. సో రైట్ హ్యాండ్ సైడ్ కెన్ బి ఇట్ ఈస్ స్టోరేజ్ టైప్. ఇది రెజ్ అయినా ఉండొచ్చు, ఇంటీజర్ అయినా ఉండొచ్చు, ఇది కూడా రియల్ టైప్ అయినా ఉండొచ్చు. ఓకే, లెఫ్ట్ హ్యాండ్ సైడ్ అండ్ రైట్ హ్యాండ్ సైడ్. సో again all the procedural assignments appear within the beginning block, so they're executed sequentially. Okay, so this I will program చేసేటప్పుడు explain this. These are some important. So first module with initial block. Okay, ఇది మీరు ఎగ్జిక్యూట్ చేయండి టెస్ట్ బెంచ్ లో కావాలంటే. సో మాడ్యూల్ నేమ్ ఇస్ nil. Okay, inputs are a b. Initial you are giving begin a tick b0, b tick 10. Okay, ఇక్కడ ఏంటిదంటే immediately you are displaying the values. A is equal to percentile by b is అంటే now here time step 0 దగ్గర a is equal to 0 and b is equal to 0 will be displayed. And after 2 time steps, what are you doing? A is equal to 1 you are assigning after 2 time steps. Okay, that means time 2 nanoseconds దగ్గర a is equal to 1 you are assigning. What is your b? B is nothing but 1 you are assigning. Okay, so no, b is equal to 0 only. So again 2 plus 3 is equal to what? T is equal to 5 దగ్గర b value are changing it to 1. 5 plus 1 is equal to t is equal to 6th time step దగ్గర a value you are changing to 0, b value will be 1 only. Okay, so this will run for 100 till t is equal to 100. Okay, ఇవే మాత్రమే ఎగ్జిక్యూట్ అవుతాయి. వాట్ ఎవర్ t is equal to 6 దగ్గర ఉన్న వాల్యూస్ t is equal to 100 వరకు కంటిన్యూ అవుతాయి. Then you are stopping your simulation. Okay, so this is a small program. Try చేసినా ఒకటే, ట్రై చేయకున్నా ఒకటే. This is the output. Okay, display command యూజ్ చేశారు. This is $monitor. Display is displaying only once. మళ్ళీ మీరు మానిటర్ యూజ్ చేశారు కాబట్టి it is continuously, whenever there is a change in the value of the output, it is displaying. Okay, so here also we will be using $display one time activity, $monitor is a repeated activity. So ఇది చాలా ఇంపార్టెంట్. మీకు ఇంటర్వ్యూలో అడిగే పక్కా క్వశ్చన్ ఇది. ఇట్ విల్ బి ఎగ్జిక్యూటెడ్ వెన్ ఇట్ ఈస్ ఎన్కౌంటర్. ఇది ఓన్లీ it will be once in simulation routine. Okay, this task may appear many times in the module. It is executed every time it is encountered. dollar monitor is a repeated activity. ఇది గుర్తుపెట్టుకుంటే చాలు. It is one time activity, is a repeated activity. Whenever there is a change in the value of A or B or input, or whenever there is a change in the output value, that value will be displayed. Okay, so only ఇప్పుడు డాలర్ డిస్ప్లే అయితే మీరు కంటిన్యూస్ మానిటరింగ్ కి డాలర్ డిస్ప్లే ఈచ్ అండ్ ఎవ్రీ టైం మీరు యూస్ చేయాలి. ఓకే, సో ఒకసారి యూస్ చేస్తే ఒక వాల్యూనే ప్రింట్ అవుతుంది మీకు. ఓకే, బట్ డాలర్ మానిటర్ లో ఒక్కసారి మీరు డాలర్ మానిటర్ యూస్ చేసిన రిపీటెడ్లీ వెన్ ఎవర్ దెర్ ఇస్ అ చేంజ్ దట్ వాల్యూస్ ఆర్ ప్రింటెడ్. ఓకే, సో దట్ ఈస్ వాట్ హియర్. So multiple initial blocks, you can use it like this, reg AP. మీరు initial dollar monitor, initial begin. So మీరు today you try this thing also. మీరు multiple times initial blocks use చేసిన, single time initial blocks use చేసినప్పుడు say take this program only. Okay, just to take this program only. ఇక్కడ ఏంటంటే ఫస్ట్ యూ డోంట్ కీప్ ఎనీ ఇనీషియల్. ఇక్కడ మీరేం పెట్టకండి. ఓకే, సో ఇక్కడ నుండి ఇక్కడ వరకు డిలీట్ చేసేసి యూ ఎగ్జిక్యూట్ ద ప్రోగ్రామ్ అండ్ అగైన్ హియర్ యూ డిలీట్ ఎవ్రీథింగ్ అండ్ కీప్ ద ప్రోగ్రామ్ యాజ్ ఇట్ ఈస్. ఓకే, so with single initial and with multiple initial blocks, you try executing this program. Let me see the output. Tomorrow we will discuss the rest of the things. Today's assignment is ring counter. You have to do ring counter. You should get the output correctly. And multiple initial blocks and single initial block. Okay, you can take any test bench program using the initial block multiple times. 3 times use చేయండి. Else you can use the initial block one time. You observe the difference. Okay, so we'll discuss the rest of the things tomorrow. If you have any doubts, you can ask me, or else we will close the session. Okay, we will discuss tomorrow.